Have you ever wondered how data is transferred over the internet? The answer lies in sockets. This might sound like an alien concept to some, but rest assured, it's as earthly as it gets, and it's what makes the internet, well, the internet. Sockets are the unsung heroes of our digital age, the invisible conductors orchestrating the symphony of data transfer that weaves the World Wide Web. They are the building blocks of network communication, the portals through which information travels across the vast digital landscape. Whether you're sending an email, streaming a video, or just browsing your favorite social media site, sockets are working tirelessly behind the scenes, facilitating that seamless interaction. They form the foundation of internet communication, an integral component that often goes unnoticed in the grand scheme of things. So, let's delve deeper into this intriguing world of sockets and their role in the vast realm of networking. To understand sockets, we must first understand what they are and where they fit in the networking hierarchy. So, what is a socket? Think of it as an endpoint in a two-way communication link between two programs running on the network. A socket is not a protocol, but rather an interface for programming network communication. It's like an open door through which data can pass between two different programs, regardless of where they're located on the network. Now, where does a socket fit in the networking hierarchy? Networking has a layered structure, with each layer performing a specific task. The lowest layer is the physical layer, which deals with the raw data transmission. Above it is the data link layer, then the network layer, the transport layer, and finally, the application layer. Sockets reside in this topmost application layer, and they provide an interface for the application to interact with the network. But how does a socket know where to send data? Here's where IP addresses and ports come into play. You can think of an IP address as a house address, and a port as a specific room within that house. When a socket wants to send data, it needs to know the IP address, or the house, where the other program resides, and the port, or the room, where the data should be delivered. In the context of sockets, the combination of an IP address and a port is called a socket address. This unique identifier allows the data to reach the correct destination. It's also worth noting that there are two types of sockets, TCP and UDP. TCP, or Transmission Control Protocol, is like a phone call. It establishes a direct, reliable connection. UDP, or User Datagram Protocol, is more like sending a postcard. It sends data without checking if it arrives. Each has its uses, which we'll delve into in the next scene. As you can see, sockets are an integral part of the networking architecture, acting as gateways for data communication. Now that we have a basic understanding of sockets, it's time to explore how they work. Dive with me into the heart of the internet, where sockets, the unsung heroes of networking, perform their magic. The process of data communication over the internet involves 4 key steps: socket creation, connection, data transfer, and closure. First up, socket creation. It's like setting up a telephone line. You need an address and a port number. The address is like the telephone number, and the port is like the extension. Together, they form a unique identifier for communication. The socket is created using the socket function, which specifies the address family, type, and protocol. Once created, the socket is ready for connection. Now let's talk about connection. This is where the magic of the internet happens. The socket created on your device connects to a socket on the server using the connect function. This is akin to dialing a number on your telephone. The server accepts the incoming connection using the accept function, and voila, a connection is established. The third step is data transfer. With the connection established, data can flow to and fro between the client and the server. This is done using the send and receive functions. It's like having a conversation over the telephone. You talk, they listen, they talk, you listen. The data transferred is usually in the form of bytes, and protocols like TCP and UDP ensure that the data is sent reliably and in order. The final step is closure. When the data transfer is complete, the socket connection needs to be closed to free up system resources. This is done using the close function. It's like hanging up the telephone after a conversation. The socket connection is terminated and the resources are freed. But what about protocols? Well, they play a critical role in socket communication. Protocols like TCP and UDP govern how data is sent and received over the network. TCP, or Transmission Control Protocol, is like a reliable postman. It ensures that all data packets reach their destination in the correct order. UDP, on the other hand, is like a speedy courier. It delivers packets quickly, but doesn't guarantee their order or arrival. Depending on the requirements of the application, either TCP or UDP is used, so the entire process of data communication over the internet, from opening a socket to closing it, is governed by these steps. Whether you're streaming your favorite TV show, video chatting with a friend, or browsing the web, sockets are working tirelessly in the background, facilitating seamless communication. They truly are the unsung heroes of the internet. Sockets come in various types, each designed to cater to a specific communication need. First off, we have stream sockets. These are the most common type of socket, and they provide reliable two-way connection-based byte streams. Think of these as the reliable mail carriers of the internet. They'll make sure your data gets to where it's going, and they'll confirm when it's being delivered. They're used in applications where you can't afford to lose any data, like when you're sending an important email or uploading a document. Next in line are datagram sockets. Unlike their stream counterparts, datagram sockets are connectionless. They're like the postcards of the digital world. You send them off and hope they reach their destination. There's no guarantee of delivery, and the data might arrive out of order or not at all. But they're fast and efficient, making them great for applications where speed is more important than reliability, like streaming video or online gaming. And then we have raw sockets. These are the Swiss Army knives of sockets, giving you direct access to the underlying communication protocols. With raw sockets, you can craft your own packets, decide how your data is sent, and interact with the network at a lower level. They're not typically used for everyday applications, but they're invaluable for network engineers and researchers who need to test or debug network systems. Finally, there are sequenced packet sockets. These combine the best of both worlds. They're connection-oriented like stream sockets, but they also maintain the record boundaries like datagram sockets. They're used in specific systems that require both reliability and speed. In the world of networking, sockets are the unsung heroes. They're the workhorses that carry our data, our messages, our videos, and our games across the vast digital landscape. Each type of socket has its own unique characteristics and use cases, and understanding these can help us design more efficient and effective communication systems. So, the next time you're streaming your favorite show or sending an important email, take a moment to appreciate the humble socket. Understanding these socket types and their uses can help network engineers design more efficient data communication systems. So, to recap, sockets are the cornerstone of internet communication. They are the essential building blocks that make the magic of internet connectivity a reality, allowing devices to communicate and exchange data across networks. Without them, our world of instant communication and data sharing would cease to exist. The basics of sockets are pretty straightforward. They're an endpoint in a two-way communication link between two programs running on a network. They provide a standardized way for these programs to send and receive data. Picture them as the digital equivalent of a telephone receiver, connecting two parties for a conversation. The working of sockets is an intricate dance of connection, communication, and termination. A socket is created, a connection is established, data is exchanged, and finally the connection is terminated. This cycle repeats millions of times a day across the globe, enabling the seamless functioning of our digital world. And let's not forget the different types of sockets we've explored. Stream sockets, also known as TCP sockets, ensure that data is delivered in the exact order it was sent, making them ideal for applications where data reliability is critical, like sending an email or loading a web page. Datagram sockets, or UDP sockets, on the other hand, prioritize speed over reliability, making them perfect for applications like streaming videos or live gaming where a bit of data loss is acceptable. In conclusion, the world of networking is a fascinating one, and sockets are one of its most vital components. They underpin almost every aspect of our digital lives, enabling the smooth flow of data that powers our emails, web browsing, video streaming, and so much more. Remember, every time you send an email, browse a web page, or stream a video, sockets are working behind the scenes to make it all possible. So the next time you find yourself marveling at the wonders of the internet, take a moment to appreciate the humble socket, quietly working a way to connect our digital world.